In this video, what's going to be described is Faraday's law. And Faraday's law says that an electromotive force is induced when a magnetic flux through a loop is changed. So let me just write a picture, or draw a picture, or attempt to draw a picture. We have a loop here, all right? And what we're going to do is we're going to pass a magnetic field through this loop, as such. We're going to pass a magnetic field through the loop. And what happens, and what we can write, is that the electromotive force is equal to the negative of the change of the magnetic flux through the loop over some period of time, is how we can write that. Remember that our magnetic flux is equal to the sum of the magnetic vector times the area vector. All right. Now, this is great if we happen to have one loop. But what if we have n number of loops? So we happen to have n number of loops. We have a tremendous. We have several loops. Well, if an induced current is going to be produced in one of the loops, it will be produced in all the loops or in all the turns. And so the electromotive force going through an n number of loops is going to be the number of loops times the change in the magnetic flux with respect to a change in time. Another way you can look at this is that this term right here would be the electromotive force in one loop, and you would multiply it then by n number of loops that exist in the system. All right, now let's look at something a little bit different. Let's say that what we're going to do instead is we're going to change the direction in which the magnetic field interacts with the loop that we have. So let's say that we're going to now change, I'll just use a solid line. We're going to now change our magnetic field. The angle of it. It's still going to have the exact same strength, but we're going to change the angle of that. How do we represent that? And let me go back. This becomes important because once the magnetic field comes to steady state and it's no longer changing, then the induction of the current ceases. It's done. And therefore, what we can do is we can now write an expression for changing of the angle between the magnetic field and the loop. And so our change in the magnetic field is going to be equal to a negative change in the magnetic field times the area times the cosine of the angle of that change. All right, so whatever angle we change. Now remember, this angle is going to be relative to the normal of the loop divided by a change in time. Try to draw that a little bit better so you can see that. There. I think my marker's dying. And this represents changing the angle that is of the magnetic field that is impingent upon the loop. Now, what can we learn from this expression? What can we learn from this expression? Well, what we can learn is that, one, the beta can change with time. And what I mean by what are we learning is how can we get this induced electromotive force or this current? How can we do it? Well, we can change the strength of the magnetic field. The second thing we can do is we can change the area of the loop, right? So this would be number one, we can change the magnetic field. Number two is we can change the area of the loop. Now this is all with respect to time, right? with respect to time, with respect to time. The third thing we can do is that we can change the angle. Change the angle in which the magnetic field interacts with the loop. Now, obviously, this is with respect to time. And the fourth thing we can do is we can change any combination of the three. And that would be either the magnetic field, the area, or the angle in which the magnetic field is being impinged upon or is interacting upon the loop. And this is obviously going to be, once again, with respect to time. So for a quick review on Faraday's law simply states that as the magnetic flux changes, right, the flux is going to be the magnetic field times the area. As that changes, there is going to be an induced current in this loop. Now, the moment that flux comes to steady state and there is no longer a change, then the induced current ceases to exist. Now, how can you keep this induced current going? Well, you can either change the magnetic field, you can change the area, or you can change the angle. All that with respect to time, or any combination of those three will result in an induced current. And if you have any questions on Faraday's law, you're free to ask me.